raised to the 2x minus 1 over, oh no, minus 1 not in the exponent. Yeah. And then over x equals 2.
Over x equals 2?
Equals 2.
Okay.
Yeah. And we're supposed to e to the 2x.
Yes.
Minus 1. Yeah, sorry.
Yeah. No, it's not your fault. I should have waited to see what you wanted me to write. Okay, and what are we trying to do? Just show?
The question I had was illustrate the definition by finding the largest possible values of theta that correspond to epsilon 0.7 and epsilon 0.2.
That's what I was asking. So epsilon equals 0.7?
Yeah.
Okay. So we're asked to find delta, correct?
Yes.
Good. So we know the definition that for every epsilon positive, there exists a delta positive such that 0 less than absolute value of x minus 0, but it's just x, less than delta, will imply e to 2x minus 1 over x minus 2 in absolute value less than 0.7. Is everyone comfortable with this so far?
Yes.
Perfect. So this is where we start, and we have to solve this inequality, like we did towards the beginning of the class today. Less than e to 2x minus 1 minus 2x over x less than 0.7. However, in this situation, I have to solve two equations, and I can't. I have to use the calculator. I have to solve the first equation, which is e to 2x minus 1 minus 2x over x equals 0.7. And I have to solve the other equation, which is e to 2x minus 1 minus 2x over x equals negative 0.7. So let's grab our calculators. I'm going to move 0.7 to this side and set it equal to 0, which is the same thing. But careful how we, didn't mean that. Careful how you plug it in. And let me clear that plot because it will not allow me to graph. Okay. Don't forget to put left parentheses. So when you put this in the graphing calculator, you have to have parentheses around the numerator. Because the denominator is just one term, it's okay without parentheses, but the numerator needs parentheses. And then I'm going to subtract this and then add this. So completely separately, I'm going to solve the first one and the second one. Okay. So in y equals, I put the left parenthesis, e to 2x. And you know me, I need parentheses everywhere. 2x, close the parenthesis. Depending on the type of calculator you have, this one does not require that many, but you know me already. First, I don't know what type of calculator you have. So I have to be mindful of everyone. And then minus 0.7. And I am going to go to the viewing window. I have no idea, or zoom if you want. I have no idea what to graph, but I know for sure that the action is close to 0. So because of that, I'm going to use a viewing window. Maybe that's better. Let's say between negative 5 and positive 5 for x with a scale of 1. I'm not sure what to select for this, but I'm looking at close to 2. So x is close to 0, the limit is close to 2. So obviously it has to include 2. So I'm going to say y minimum, let's say negative 2 with positive 5, let's say. I may adjust later, we'll see in a minute, and with a scale of 1. And I'm going to hit graph and see what happens. Okay, so the action as expected is around it's around 0, left and right of 0. And I'm looking for the x-intercept. of this, when all this is 0, which means this point right here. So I see it's between 0 and 1, so I'm going to try to find the solution, which is x, that makes this to be 0. So I have several options. I can go to second and calc right here, where it says trace, and I want a 0. The 0 of this function, in other words, where it's 0 or the x-intercept. So I press enter. The calculator will ask me to give it a bounded area. So I'm going to give 0 and 1. So 0 for the left bound, 1 for the right bound, and I say just give me the answer finally. So they say, the calculator says 0.28646. So here x equals 0.28646. I will repeat for the plus. So go back to y equals. I will change the negative 0.7 with positive 0.7. And then I go back to the same thing and I create second and calc, and I want a 0. And let's see, it's going to graph a new function. Here it is. And now I see the x-intercept, or the 0 of this function, or the solution of this equation, is somewhere between negative 1 and 0. So I give a left bound as negative 1. I give a right bound for as 0, and I say, I don't want to guess, just give me the answer. And it gives me as x being negative 0.466847. And I know that delta has to be, first of all, a positive number. So then delta, I don't know how many decimal digits they want. I don't know, did they say how many decimals? So delta is the minimum number from two absolute value numbers. So how many decimal digits did they want?
Said 3.
Okay, so I'm going to have to choose this one, 0.286. This problem cannot be solved without the use of the graphing calculator, because I don't know how to solve this. I will know how to solve it in chapter 4 using Newton's method, but right now I don't. So my only chance is the graphing calculator, finding those two solutions. Very interesting problem. Thank you for bringing that up. Does it make sense? Are the steps clear?
Yes, thank you.